Good morning to all. I am Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, we will discuss about the face-centered cubic structure. So, previous, we have seen that simple cubic crystal structure and then body-centered cubic structure. Now, we'll see that face-centered cubic structure, what are the characteristics of that face-centered cubic structure. So, face-centered cubic structure, it consists of atoms at 8 corners and each face has a center atom. So, if we take any of the cubic crystal which is related to face-centered, so this is a cubic crystal. As we know that each corner there exists an atom. Along with that, in every face of this cubic crystal, so this is one of the face and this is also one of the face, and here it is top face, in front side, and here in this it is left side, and as like this back side also there is another face, and the top side as well as bottom side also we have faces of this cubic crystal. So along this corner atoms of this cubic crystal, at each face there is an atom which is at the center of the face. So face-centered cubic structure consists of atoms at 8 corners and each face has a center atom. So in this face there is an atom, and here in this face, front face, there is an atom. Like here in this face there is an atom, and top, the bottom is the front side as well as back side. At each face there is an atom at the center. So what are the parameters here in this crystal? So the crystal structure parameters are what type of unit cell it is. So it is cubic unit cell, and the lattice parameters A, B, C all are equal as we have taken cubic crystal. So all the dimensions are same. So A is equals to B is equals to C, that is equals to lattice constant. Here interfacial angles alpha is equals to beta is equal to gamma. So all the dimensions be the same, which is at 90 degrees. And here the primitive cell. So is it primitive cell or not? So as we say, a primitive cell which consists of only one atom in the unit cell, then we call it as primitive unit cell. But here, in addition to corner atoms, it consists of face-centered atoms. So it is not a primitive unit cell. So it consists of a center atom along with the corner atoms. So it is not a primitive. So it is not a primitive because along with the 8 corner atoms, there are another atoms also which is at the face of the cubic crystal. Effective number of atoms in unit cell. So effective number of atoms in unit cell. So a face-centered cubic unit cell consists of 8 corners. In 8 corners there are atoms. So and 6 face-centered atoms. So a face-centered cubic unit cell consists of 8 corner atoms and 6 face-centered atoms. So a face-centered cubic consists of 8 corner atoms and face-centered atoms also. So how it will be? So in this diagram, you can see that in the first picture, these are the corner atoms which are at green. So the green color shows the atoms which are at the corner of the cube. Along with the corner atoms, there is a pink color atoms also be there. So these pink color atoms shows that these are the center atom of each face. So this is the atom which is at the center of the front face of the cubic crystal. As like this is of right side, and here this is for left side face, and this is top, and here the bottom, as well as here the front side there is an atom front face, in the front face. Like the same backward also, at the center there is an atom. So you can clearly see that. So here corner atoms, green color. So this is one of the face. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7. So 8 corner atoms. So which is represents in green color, which is showed in green color, and each face there is an atom which is at the center. It shows pink in color. So front face it is 1, and back it is second atom. I mean, I'm counting each face the atom were there. And left, this is the third. Likewise, right, fourth atom, and top 5, and bottom 6. So 6 faces, 6 center atoms. Okay, and each corner, at 8 corners we have corner atoms, 8 corner atoms. So they are being shared like this in the diagram, third diagram, which is shown in this. So a face-centered cubic consists of 8 corner atoms, and face-centered atoms, as have seen in the figure. Each and every corner atom is shared by 8 adjacent unit cells. 8 adjacent unit cells. So that's why a part of the atom is being in this unit cell. It is not complete atom. It is not complete atom. So if we want complete atom, there are adjacent unit cell which is clubbed together, because a crystal is formed by building of unit cells. Okay, so unit cell is a building block of the crystals. So like so that this is the atom which is a part in this unit cell. Okay, like that every atom which is at the corner are being shared with the adjacent unit cell. So therefore each and every corner atom contributes 1/8 of its part to one unit cell. So each and every corner atom contributes 1/8 of its part to one unit cell. So the total number of atoms contributed by corner atoms is 1/8 part into 8 corners, so that we'll get one atom. We'll get one atom. So 8 corners, and each corner 1/8 share of an atom. So 1/8 into 8 is equal to 1 atom. So each and every face center atom is shared by 2 unit cells. So in this diagram, so we have seen the corner atoms. So 1/8 share, total 8 corners, so 1 atom. So this is of only about the corner atoms of the cubic crystal. So here, along with this, each and every face-centered atom is shared by two unit cells. So here in this face, the pink color atom, so which is at the center of this face, so it is being shared with another unit cell. So of the atom half of the atom is at this unit cell, half of the atom be in the adjacent unit cell. So each face center contributes half of its part to one unit cell. to one unit cell. So a face-centered atom contributes half of its part to one unit cell. So the total number of atoms contributed by the face-centered is 1 by 2 into 6 is equals to 3. So because each face, the shared atom at the center is half, so half into totally 6 faces. So 6 faces is equals to 3. So totally at each face, the contributed atoms are 3. So this is at each face. So face centered atoms. So 3 atoms are contributed in the face center of the cubic crystal. So therefore, what is the effective number of atoms in unit cell? So the total number of atoms present in the FCC cell is 1 plus 3 is equal to 4. So this 1 belongs to corner atoms and this 3 belongs to face centered atoms. So totally 4 atoms are contributed in the face centered cubic crystal. So coordination number. So let us consider a corner atom in its own plane. So that corner atom has 4 face centered atoms. So the corner atom has 4 face centered atoms. So these face centered atoms are its nearest neighbors So nearest neighbors, when we tell nearest neighbors, which are at the distance of 2 or. So which are at the distance of 2 or, they are nearest neighbors. So here we are considering an atom. So this atom in its own plane, the corner we are taking as it as a corner atom. So we are taking a corner atom in its plane, so that it has 4 face centered atoms. So these face centered atoms are its nearest neighbors. So in a plane which lies just below this corner atom, it has yet 4 more face centered atoms as its nearest neighbors. So therefore, an atom in FCC unit cell, the nearest neighbors is 12. The nearest neighbor is 12. So we can calculate the atomic radius. So R value. So for face centered cubic unit cell, the atomic radius can be calculated by taking triangle of ABC from the diagram. ABC. So AC square is equals to AB square plus BC square. So AC square is 4R square, because So here to here r distance, here to here r distance. So here to here 2r distance. So totally A, B. Oh, so AC, the distance is 4r. So AC square is equals to 4r square, that is equals to a square plus a square. What is this a square? AB. The edge length is A, as we have taken cubic crystal, so that the dimensions are same. So A is equals to B is equals to C, that is equals to lattice constant. Already in the first slide we have seen. And interfacial angles, alpha is equals to beta is equals to gamma, that is equals to 90 degrees. So the edge length of this cubic crystal is same. So all the dimensions are being the same. So edge length is, so that in case we can write A is equals to A. That is all the sides A, like that. So AB is equals to A, BC is equals to A. So 4R square is equals to A square plus A square. So 16R square is equals to 2A square. So the atomic radius R is equals to A by 2 root 2. So that is 16R square is equals to 2A square. So R square is equals to 2A square by 16. R square is equals to A square by 8. So now R is equals to root of A square by 8. So that is equals to A by 2 into root 4. So A by 2 root 2. So the atomic radius is R is equals to A by 2 root 2. So in this picture clearly you can understand how the corner atoms are being shared and how the face-centered atoms are shared with the adjacent unit cell. So this is of for only one unit cell. We have taken only one unit cell and we are calculating the lattice parameters and then characters. Okay, characteristics. So here the effective number, how we can taking this effective number of the atoms in the cubic crystal. So half atom at 6 faces, corner atoms. Sorry, half atom on each 6 face, that is. So here 1/8 of atom at 8 corners. So this represents corner atoms. This represents corner atoms. So here this represents face center atoms. Nearest to neighboring distance. So which are at 2r. So radius is r is equals to A by 2 root 2. And nearest to neighboring distance 2r is equals to 2 into r is equals to A by 2 root 2. So 2r is equals to 2 into A by 2 root 2. So it is equals to A by root 2. So 2r is equals to nearest neighboring distance. 2r is equals to A by root 2. Next, coming to the atomic packing factor. So how much percentage of space is occupied by the atoms in the unit cell of the cube. So the atomic packing factor of a face-centered cubic unit cell can be calculated by taking the number of atoms and number of atoms occupied in the unit cell, and then volume, how much it is occupied, and remaining the things. So that is atomic packing factor. We know that the formula number of atoms into volume of the atom divided by volume of the unit cell. So we are considering number of atoms present in the unit cell. Already we have been calculated. So that is 4. This 4 is included of corner atoms plus face centered atoms. So totally 1 plus 3 is equals to 4. So we have obtained previously. So the number of atoms present in the face centered unit cell is 4, and volume of one atom is 4 by 3 pi r cube. 4 by 3 pi r cube. And volume of the unit cell. So as it is a cubic crystal, so volume, all the dimensions are being same. So A is equals to B is equals to C. So that all the dimensions A, so cube. Okay, volume of the unit cell is equals to A cube. Atomic packing factor, as we said. So number of atoms, I just write APF in shortcut, atomic packing factor, or packing density. Number of atoms in one unit cell into volume of one atom divided by volume of the units. So this is the formula. So number of atoms is 4, and volume of one atom is 4 by 3 pi r cube. So volume divided by volume of the unit cell is A cube. So now already we have calculated R value, radius, atomic radius. So R is equals to A by 2 root 2. So this is substituted in the above equation. So 4 into 4 by 3 pi. So instead of R, we have substituted A by 2 root 2 whole cube divided by A cube. So that is equals to A by 2 root 2. That is equal to pi by 3 root 2. Okay. So here can be calculated 4 by 3 pi A cube by 2 root 2 divided by A cube. So this can be 16 pi by 3 into A cube by 8 into whole cube divided by A cube. So 2A cube by 3. This can be written as 2 root 2. So that A cube. So atomic packing factor, it is equals to 2A cube divided by 3 into 2 root 2 into 1 by A cube. So A cube get cancelled, and 2 and 2 gets cancelled. So here pi is there, have missed. So pi by 3 root 2. So likewise we can get the atomic packing factor. Okay, atomic packing factor is equal to pi by 3 root 2. That is equals to, if we simplifying this one, you'll get 0.74%. 0.74. So that packing density is 0.74. So this shows that 74% of atom of the face-centered cubic unit cell is occupied by atoms. So it is very closely packed structure. It is very closely packed structure than the simple cubic crystal and body-centered cubic crystal. So comparing to the previous simple cubic and body-centered cubic crystals, it has the face-centered cubic unit cell has very closely packed structure. That is 74% of atoms are occupied in the face-centered cubic structure. Okay, so how much interstitial space? So it is of 26%. It is of 26%. So this is all about the face-centered cubic crystal structure. So we shall meet with another topic in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.